So, very good evening to one and all gathered here. So, today we are going to have some insights on metrology and quality control. So, let us see the basic objectives of metrology and quality control. So, the course on metrology quality control will provide a brief information on different equipments and measuring gadgets whose performance, working principle with respect to the given measuring standards and their practical use of application. So these are the things students will come to know in real time practice. At the same time, the metrology and quality control will give you statistics knowledge about the end results which you have obtained through measurement that can be represented using basic statistical knowledge, using different probability techniques in quality application in order to predict whether the given path is considered to be accepted or not. Say for an example, you are manufacturing 1,000 number of parts in a particular shift. So out of 1,000, how many are going to satisfy the condition as per the specification of the part? So this can be statistically inferred how many are good parts, how many are not coming under the good parts. Okay, we can decide the quality of the part according to the statistic and probability techniques. So this subject is of two phases. The first phase covers about the instrument calibration methods and its different types and use. In the second phase, which tells about the quality control application, say inspection measurement procedure for checking the dimension of the finished component. So the subject has got two different phases. Now today we will see in module 1, we will see about the basic fundamental of metrology. So what exactly the metrology it clearly tells about. So it is a basic principle of scientific measuring devices which clearly describes about how the instruments can be handled with reference to a given environment and how to find out the error, standard error, and what are the possible way to improve the accuracy of the instruments. So that's why here the metrology has been defined in such a way that it is considered to be the scientific study of measurement. The next one is how will you define the term called quality control? So the quality control which clearly says about fitting the level of excellence of a finished product that is considered to be entirely free from defects. How many products are considered to be zero, free from defects, without defects? How many are having deficiencies? In this way, we can able to classify, we can rank the good and bad part. So the quality control is a measure of excellence to identify the number of production parts that has been manufactured using machineries, tools and equipments. Based on that, how the final product is considered to be performing better without defects. Here only we are going to rely upon certain statistical methods like a P chart, NP chart, X bar and R chart. Okay, variable and attribute charts. So you must know the basic statistics principle and probability techniques. Now we will go to the exact meaning of metrology, which has been coined by the organization name called the International Bureau of Weights and Measure. So they said about the metrology, it is nothing but the scientific study of measurement which connects both theoretical principle and the experimental working concept in order to understand the uncertainty of the measurement in the field of science and technology. So every measurement variable will have certain uncertainty. Here in this subject, we want to discuss the different level of uncertainty pertaining to the error in a given apparatus. So you take a vernier caliper as a for an instance. Okay. So what are the different kinds of error the measuring instrument will have if you do not able to calibrate well? Then error due to environment, error due to the contact, poor contact between the supports, then error due to improper location of the part between the two measuring phases. So these are some kind of errors that we can able to witness if the instrument is not properly handled. So these are called as uncertainty because the level of accuracy is we cannot able to predict it as exactly as possible. So there are certain deviation away from the given fixed standard variable. So that's why to improve the accuracy of the instrument, so we are supposed to take 5 or 10 set of observation the trial in every now and then, in every occasion, in order to minimize the fluctuation due to the uncertainty problem in the measuring instruments. What are the basic purpose of metrology? First one is prepare the proper design or layout of each measuring apparatus, including the special inspection fixtures, if there is any such thing. Then standardize the working method for measuring devices. That is calibration manual should be supplied by the authority. Then determine the capability of the instrument based on the corresponding measurement. Accordingly, we can able to quantify the error, maintain the accuracy of the instrument by doing proper calibration every month, and minimize the cost of inspection by doing the efficient way of handling the instrument by minimizing the number of rejects due to the unwanted failure issues. So this can be done using statistic quality control techniques. So with the help of the statistical quality control techniques, we can define the population size or batch size or by considering a lot. So take a few random sample from the whole lot, try to do the quantitative analysis. If the given the product dimension fits within the controllable allowable limit, then it's okay. So we can able to reduce the number of rejection of part in a batch, or if it is more, then we have to improve the quality of the work part. Make a thorough evaluation of newly developed product or component, whether that falls within the given the tolerance limit as per the equipment capability or not. So these are the different basic purpose of study in metrology system, metrology and quality control. Now let us go with the different types of metrology, say scientific metrology, applied metrology, and legal metrology. These are the three basic forms of metrological systems. So the first one, let us come out with what do you mean by scientific metrology? So this kind of measuring standard or a system normally followed by the primary research and development organization for making any commercial products. Let us say, for example, so The scientific metrology, the instruments that has been manufactured by them will stick on to the establishment of national measurement laboratory standards. So what is the duty of the National Measurement Laboratory? They will try to compare the dimension of the material with the reference to the standards. Then based on that, they will update all the standard parameter with the proper establishment with reference to the international standards. And finally, they will go for updating, maintenance, and implementation. So these are the daily routine work carried out by the National Measurement Laboratory. All different kinds of physical variables that are used in engineering, say for example, length, mass, time, velocity, acceleration, pressure, temperature. So these are the different physical variables. So these variables, the quantity, the numerical dimension is compared with reference to the international standards. Based on that only, they will try to establish and maintain the record properly. Let us say, for example, fundamental metrology, scientific metrology. There are different types of units of measurement: FPS, CGS, and MKA system. FPS system, foot pounds second. FPS. CGS, centimeter kilogram. MKA system, meter kilogram second. So these are the different methods of the scientific metrology. So accordingly, we can classify into two different ways. So the first one, which follows the imperial units. Okay, so here, say for example, the length can be measured in terms of foot, okay, or yard, right? Whereas the next one is a metric unit or SI unit, CGS and MKA system. So here we can able to define the same variable length in terms of centimeter or meter. This is a different unit conversion system. According to the level of the comfort, we can able to use it. Here there is the question for you to make you to think. So the scientific measurement study that deals with either accuracy and methods of measurement, standard specification, or theories related to the nature, or all of the above. So which answer suits out for the given question? So as we discussed earlier, the previous few slides, the scientific metrology basically establish the instrument accuracy and also following the proper method, the procedure of measuring the unknown variable, then verifying the standard specification, updating the theories of measurement related to the practical nature. So answer is all of the above, option D. So the study of scientific metrology deals with all the basic essential characteristics. Now let us see the next one, applied metrology. So it is another measuring unit system which is used to measure the work part with the help of the conventional measuring instrument, you say vernier, screw gauge, and micrometer. So these instruments are used in industrial, particularly in production manufacturing sector, in order to find out the reliability of the machined part, how far that is able to fit within the standard design specification limit. The third one is a legal metrology. So here in this system of measuring standard, so each and every parameter of the product will follow certain standard norms and guidelines by referring to the international standard measurement manual. The activities of legal metrology is to control the capability of various measuring instruments according to the permitted limit. Say for example here, so smoke emission system in a vehicle. Okay, so there are different stages in Bharat, BS2, BS3 and BS4 in order to regulate the pollution control norms in the vehicle. So as per the standard norms, so the vehicle should follow the standard procedure fixed by the government of India in order to safely adequate to the standards as mentioned by the higher authority regarding the pollution hazards coming from the vehicle. So here there is another multiple choice question which is kept here. So what is the main purpose of quality assurance? So here are the options. So it is a measurement of degree to which the product satisfies the need. Any systematic process used to ensure quality in the process of identifying the defects, or it is a corrective tool. So what is the answer? What do you mean by quality assurance? Which option can be suited for this question? So let us go with option A. So what is given in option A? Measuring the degree of excellence to which the product satisfies the need. No, this is not quality assurance. The next one, any systematic process used to ensure the quality in the process. So answer is option B. So quality assurance means you are guaranteeing uh, the customer about the upliftment of quality in the so-called the product which you are going to deliver to them. So quality assurance is a standard systematic procedure which justifies the quality in the daily day-to-day working process of the product. The answer is option B. So now we shall summarize what are the basic things we have gone through so far. So in the initial few slides, we saw about the basic purpose of metrology, then what are the various uh, different definitions of metrology. Then we saw about different types of metrological measurement methods. Then in between, we saw some multiple choice quiz questions. So with this, what we understood the basics of metrology. So it is a field in engineering which gives an idea about the working procedure of instrument, the corresponding calibration in minimizing the error by improving the accuracy by comparing to the known standard value. So now we will proceed the next phase of the metrology quality control subject. So next we are going to see about what is measurement. So it is a mechanical process or a physical observation. We can able to compare the dimension of unknown quantity by knowing the standard value, this predefined standard value. Say for example, you are going to find out the length of an unknown component. So first of all, you should know the standard length data. So as a benchmark reference, By comparing to the standard data, we can able to differentiate or find out the variation between the actual observed length as a parameter for compression for comparison based on the fixed standard value. What are the basic need to go for the measurement process? First thing, to find out the eligible dimensions of the part. Next one, convert all the physical dimension into a meaningful number. Say for example, so this object is so much diameter in mm. The length of the object is so much mm. So you are going to convert everything in terms of a number with a unit meter or centimeter. So for that only you are going to measure or quantify the unknown variable to estimate how much amount of variation that occurs apart from the given standard value. Then evaluating the performance of the system by utilizing the measuring gadgets in real-time environment. And also we can able to find out the process control by, of the equipment by taking a repeated set of readings. Based on that, we can able to measure the quality of the overall batch of the product using the instrument for defect checking. And it is a mass customized approach. The measuring devices normally are used in mass production system. So another one word question. So how will you define a standard? So standard is a measuring standard is a procedure which tries to optimize the hidden cost that is present in an unknown variable. So by using the standards, we can able to correct the perfect dimensions of the actual product. Okay, so that we can able to reduce the cost of rejection, wastage, etc. Which of the following error is caused by careless handling of the instrument? So these are the options. So random error. Say for example, when you are using a screw gauge or micrometer, you may not able to tighten the part which you are going to measure it between the two center or a support. Okay, due to the poor loose contact or random positioning of the specimen between the two measuring support, that may lead to random error sometimes. So avoid careless handling of the instrument. Follow the procedure as given in the instruction manual exactly. Next, we are going to see about what are the different methods of measurement, direct measurement and indirect measurement. In other ways, we can say secondary measuring standards and primary measuring standards. Which one is a primary measuring standard? First one, direct measurement. Here you can take measurement performed by scale, vernier caliper, micrometer. They are called as a direct measuring instrument device. Here we are not going to do any calculation. Directly you are going to observe the reading and you are going to take that as a final one. Whereas an indirect measurement, secondary measurement method, there we are going to do some calculation in order to convert the one form of variable into another form. Say for example, if you want to find out the density of any object, first thing you must know the mass and volume. So from that only we can able to find out what is the density of the material. Another example for indirect measurement, checking the pulse rate of the person using electrobiomechanical pressure sensing device. So here one form of input is converted into another form of an output. So what is the input here? Mechanical pressure, the help of the manometer. and that is being sensed and converted into electric signal, okay, with the help of the sensor and transducer. So for increasing the level of accuracy, and also we can able to control the error, and that increases the speed of doing the measurement process in a rapid approach without making any delay in finding the final output. So that's why I told you electromechanical application. Input may be a mechanical input, okay? Output may not be the same mechanical input. So the pressure, the blood pressure that can convert it into an electrical quantity using the strain gauge sensor. In order to accurately find out what exactly the range of the value is. What is the main role of standards used in metrology? To have a uniform consistency operation in measurement device. Okay, say for example, repeatability and reproducibility. Say for 10 observations, you are going to do uh, the dimension measurement with the help of the mechanical measuring gadgets like dial indicator or a pressure gauge. So the instrument should be able to give the same value again and again consistently. It should not lose its level of efficiency. Okay, so that's why the standards are considered to be more stressed upon in measuring instrument. So let us go with another one more question. With this, we will end the today's module one, and the next day we will start module two, the remaining further continuation in metrology and quality control. Now let us go with the question. Which of the following error is produced due to the poor calibration? So systematic error. Okay. The error which occurs repeatedly, okay, we call that as a systematic error. So how systematic error takes place? Due to poor calibration of the apparatus. So periodically we have to do the calibration in controlling the range of error as minimum as possible. Okay. So with this information, today I close module one. So thank you one and all. Tomorrow we will, next slide onwards, we will discuss about the module two, the further information on metrology and quality control. So once again, I thank each and every one of you